Hello, hello, and welcome to Current Events in Astronomy. My name is Matt Dotson. I will be running board and engineering this episode of the podcast. I'm joined in studio by my co-hosts Andrew Jorgensen and Tor Fredericks, and they have a couple questions for our guest, Dr. Paul Cooper, a Mason faculty member who specializes in astrochemistry. So, Dr. Cooper, Tor first met you when you gave a presentation at the observatory. So could you touch back on what your presentation was about?
Sure. I mean, essentially what it was about was trying to find places in the universe, specifically our solar system, but everywhere else in the universe, places where you're likely to find life. So there are certain requirements needed to be able to sustain life. We know things like you got to have access to liquid water. You got to have access to what we call organic molecules that basically build biological life that we know on Earth. So it was a sort of an overview of that topic, but specifically the angle that I was looking at was the overview of energy. So all biological life needs energy somewhere in order to be able to sustain itself. So maybe instead of looking for liquid water, maybe instead of looking for organics, maybe we can look for sources of energy, and maybe that could point us in the right direction of where we need to look to try and find life.
All right, so that's great. So I'm hearing water, I'm hearing molecules, specific molecules or elements that are required for life, and then energy. Any other kind of nuts and bolts scientific stuff that we need to have a little background on before we kind of delve into the theory or your research?
Well, I mean, there's basic laws of thermodynamics, but we probably don't need to cover those here. Okay. There are certainly, there are rules by which the universe has to play in terms of being able to do things chemically and being able to do processes. But I think the main thing that for the general audience is we need some kind of energy source. I mean, in a scientific sense, we'd call that an energy gradient. We got to have high energy and low energy, and we got to flow energy from one place to another, essentially, in order to get these processes occurring.
Okay. All right. Sounds good. So now that we have, I guess this is an overstatement, but a rudimentary understanding of like at least the core background things, let's dig into it. Can you explain your hypothesis?
Well, some of the examples that I went through in my talk were looking at, for example, places in the solar system like Europa, which is a moon of Jupiter, or even Enceladus, which is a moon of Saturn. So these are icy satellites that are being exposed to radiation.
Okay, and where does that radiation come from?
So that radiation actually comes from it's particle radiation. So these are highly charged, not highly charged, I guess. They're charged species that are highly energetic that get trapped within the magnetic fields of the parent planets. So Jupiter has this massive magnetic field that is able to trap these charged particles, and it redirects them onto the surfaces of their moons. Okay. So Europa, for example, is just the surface is completely saturated in all of this energetic radiation. The effect that this radiation has is to go through and basically blow apart all of the water molecules and any other kind of molecules that are there on the surface. The result of that chemistry creates molecules that provide now that energy. Okay. So one of the main products that's formed through that process is molecular oxygen. Guess what? We use molecular oxygen.
Sure.
Right?
Good for the breathing.
Yeah. Right? Everyone needs a good little bit of oxygen, right? So if you have this oxygen that's on the surface, one of the things that we know about Europa is that it's more than likely to be tectonically active. And the reason we know that is you can look at the crater history. So there's basically very little craters on the surface of Europa. Why? Because tectonic activity has kind of wiped them all out.
Okay.
So if you can produce this oxygen at the surface and you can somehow transport it down into, guess what? There's an ocean on Europa that's beneath the surface. So if you can get that oxygen down to now where there's liquid water, there's probably going to be organics there, and there's now conditions where you have all of your ingredients, including your energy, to be able to perhaps sustain life.
Now, you mentioned tectonics, so the energy is coming from the tectonic action or from the irradiated particles?
The tectonics is literally just transporting things, right? The energy itself is coming from the radiation. So just like there's a transfer of energy from the sun through photosynthesis to sustain life on Earth, there would be a transfer of energy from this radiation that's coming in as particle radiation that ends up then being delivered, facilitating other processes. Yeah.
Okay. All right.
So I'm going to ask the pressing question. Life in the universe. Do you expect us to be able to corroborate your theory within your lifetime, or like what's the timeline?
Can I go to Vegas and get odds on this?
I mean, I think you have a certain amount of validity to it. It sounds like it's feasible.
It's definitely intriguing. For
All right.
sure.
So I mean, if you were saying this during the golden age of space exploration, in the late 60s, early 70s, perhaps you would have said, yes, within the next 30 years, we would find maybe life. And guess what? We're nowhere near finding than we were then.
Understood.
So there's a chance, but it's actually pretty difficult to find life just by using a spacecraft, right? So imagine we lived on Mars and you sent a spacecraft off to Earth and you just stuck it in orbit. Could you look at the surface and figure out there's life on the surface of Earth? Well, you'd have to zoom in, right? You'd have to start seeing people walk around. Well, Europa, we're not going to be seeing whales and fish and whatever else swimming around the ocean because the ocean's buried under tens of kilometers of ice. So trying to access that is the hard part. Now,
are you saying we have a spacecraft going to Europa?
Yes, there is a spacecraft going to Europa. The Congress has approved it. It will be launching sometime in the mid-2020s. It'll be going on the new space launch system that NASA are building, and it's in the instruments have all been selected. It's just a matter of them building this thing now.
Wow, that's great. Well, thank you very much. I know I was extremely intrigued when I first met you, so I'm glad that you actually reiterated and kind of hashed out some of the topics here. Thanks for spending time with us today.
No problem.
Appreciate
Thank
it.
you.
Yeah, thank you.